Hello everyone and welcome to my YouTube channel. From today up to the next few weeks or months ahead of us, we'll be looking at the topic partial differential equation, which we normally shorten and call it PDE. To get more updates and videos on this particular topic, kindly hit on the subscribe button to get notification whenever I upload any video on this very topic. When we talk about PDE or partial differential equation, it falls under a very broad topic called the differential equation. When we talk about differential equation, we are referring to a mathematical equation which contain one or more unknown functions, which we sometimes call it dependent variables, with respect to one or more independent variables. Then we can say that that mathematical equation is a differential equation. Now, differential equation can be classified according to the number of variables involved. It can be classified according to what? The number of variables involved. When we talk about the variables, we are referring to the independent variables. So when you have a differential equation which contains ordinary derivatives, ordinary derivatives. So when we talk about the ordinary derivatives, then we are referring to our dy dx. So when you have a differential equation which contains ordinary derivatives of one or more unknown functions with respect to only one independent variable, then you can say that that differential equation is an ordinary differential equation, which we sometimes call it the ODE. So with the ordinary differential equation, we'll be looking at only one independent variable, only one independent variable. So you could recall when you were looking at ordinary differential equation in your previous course, you realized that you came across examples such as dy dx plus y is equal to. So this is an example of a first order differential equation. And we are saying that this is an ordinary differential equation because it contains only one independent variable. Now, when we talk about the independent variable in this equation, then we are referring to the variable that we are taking the derivative with respect to. So looking at this, we are taking the derivative of the function y with respect to x, and x becomes what? Our independent variable. So in this equation, we only have only one independent variable, and that is what? X. And y here becomes our function or the dependent variable. Now we can write this using another notation. We can write this as y prime at x plus y is equal to 0. So we are taking the derivative of the function y with respect to x. And therefore, the variable that we are taking the derivative with respect to becomes the independent variable. So in this equation, our dependent variable is only one, and that is what? X. Another example of an ordinary differential is a second order differential equation, which can be written as d squared y dx squared plus 5 dy dx plus 6y is equal to 0. This is also an example of ordinary differential equation because we are having only one independent variable. So from this equation, what is our independent variable? Our independent variable is the variable that we are taking the derivative with respect to. So we are taking the derivative of the function y with respect to x. We are taking the derivative of the function y with respect to x. And therefore, this equation becomes an ordinary differential equation because we have only one independent variable, and that is what? X. Now we can write this using another notation. We can write this as y prime prime of x plus 5 y prime at x plus 6y is equal. So here you can see clearly that we only have one independent variable, and that is what x. You can see that in each of these terms, we are taking the derivative of the function y with respect to x, the function y with respect to x. So we have only one independent variable, and therefore these and many more are examples of ordinary differential equation. Now let's look at the other classification, that is the partial differential equation. So we are looking at the other classification, which is based on the number of variables, the number of independent variables, and that is what partial differential equation. When we talk about partial differential equation, then we are referring to a mathematical equation that involves a partial derivative of a function with respect to two or more independent variables. So the key here is that with the partial differential equation, we'll be looking at what? Two or more independent variables. With the ordinary differential equation, we're looking at only one independent variable. But with the partial, we'll be looking at what? Two or more independent variables. So with the PDE, we're making use of the function u. We'll be making use of what? The function u. So when you have a function u which contains two or more independent variables, then you can say that this is what? A partial differential equation. So with this, our unknown function is what? The u, which is also or sometimes called the dependent variables, and then x, y, and z are our independent variables. So when you have a mathematical equation which contains a partial derivative of a function with respect to two or more independent variables, then you can say that that equation is a partial differential equation. Examples of partial differential equation, we can look at del u del x plus del u del y is equal to 0. So del u del x means we have to take the partial derivative of the function u with respect to x. We have to take what? The partial derivative of the function u with respect to x. And then del u del y means we have to take the partial derivative of the function u with respect to y. So let me ask you, how many independent variables can be found in this equation? And as I said earlier on, when we talk about the independent variables, we are referring to the variables that we are taking the derivative with respect to. So looking at this, we are taking the partial derivative of the function u with respect to x. So we have one independent variable, which is what? X. And with the second term, we are taking the partial derivative of the function u with respect to what? Y. So our independent variable here is what? Y. So how many independent variables do we have in this equation? We are having two independent variables. In that case, this equation becomes a partial differential equation because we are having how many independent variables? Two independent variables. We can also look at another example of a partial differential equation. Let's look at this example. This is a classical example of a partial differential equation. Now let me ask you, what is our function in this equation? In other words, what is our dependent variables in this equation? So our dependent variable in this equation is u. Our function is u from here. And we are taking the second partial derivative of the function u with respect to x. So x here is our independent variable. And we are also looking at this particular term. we have to take the second partial derivative of the function u with respect to x and then y. So this means that we have to take the partial derivative with respect to x, then after that we take the partial derivative with respect to y. So here we are still having x and then y to be our independent variable, and then with this we have to take the second partial derivative of the function u with respect to y. So we are still having y here. So you can see that we are having how many independent variables? We have two independent variables. That's for x and y, x and y. So you can say that this is an example of a partial differential equation because we are having only two independent variables and their partial derivatives. Let's look at more examples of partial differential equations. So we have some few examples of PDEs. Let's go through them to see if they are actually PDEs. So looking at this, the example 3, we have 3 times the partial derivative of u with respect to x plus 5 times the partial derivative of u with respect to y is equal to sine xy. So with example 3, our function is what? U. Our function is u, and we are taking the first partial derivative of this function with respect to x. So x here becomes our what? Independent variable. And then we also have our function here, which is u, and we are taking the first partial derivative of this function u with respect to y. So our y here also becomes what? Our independent variable. So how many independent variables do we have in this equation? We have two independent variables, and this is an example of a partial differential equation. This is also a partial differential equation because we are having two independent variables with its derivatives, partial derivatives, sorry. So with this we have the second partial derivative of the function u. So the function is u, the function is u, the function is u, and we are taking the derivative with respect to x. So we have one independent variable here. Then with this we are taking the second partial derivative of the function u with respect to x and then y. So we have two independent variables here, and then we have one independent variable here. So the independent variables are x and then y, x and y, and then x and y. So we have two independent variables. So this is an example of a partial differential equation. Now looking at these two, how many independent variables do we have? We have the third partial derivative of the function u with respect to z. So we have one independent variable, that is z. So we have one, and then we also have the third partial derivative of the function u with respect to z, y, and then x. So how many independent variables do we have? We have 1, 2, and then 3. So we have these all being independent variable, and then with respect to x, with respect to y. So it means that in this equation we are having how many independent variables? We have 1, 2, and then 3. We have 3 independent variables, and then we have the partial derivative. So this is an example of a partial differential equation. I hope you can give more examples of partial differential equations. So before we bring today's lesson to an end, I want you to classify these differential equations under ODEs and then PDEs. All of these are differential equations, and I want you to classify them under ODEs and then PDEs based on the explanation that you have gotten for today's lesson. I'm going to help you by doing 2 of them for you, and then you do the rest at your leisure hours. So I'll do the first one. So with the first one, you can see that we are having only one independent variable, and that is x. And since we are having only one independent variable, then we can say that this equation is an ordinary differential equation. So the first one is ODE. The first one is ODE. Then let me do C for you. C. So looking at C, you can see that we are having 3 independent variables. That is x, y, and z. And since we are talking about partial, this means partial derivative, second partial derivative of the function u with respect to x, second partial derivative of the function u with respect to y, second partial derivative of the function u with respect to z. Then you can see that this form of differential equation is what? Partial differential equation. So this one, PDE, this is partial differential equation. I guess you can tell me this. This is also very clear. This is also very clear. This brings us to the end of today's lesson. See you tomorrow. Bye bye.